Okay, we're back, and if only we had something interesting. But okay, well, okay. Hello there, hello then. Okay. So we hopefully had a good time with our simplifying and just relaxed lesson yesterday, and let's head into exponential equations. So for this one, you can see our strategy written here, and what I'm going to try for this one, just kind of go a little, not that much different, and I'm just going to bum through them because I want to go through their like 5 examples. I want to go through them really quickly, and then we're going to kind of look at the concepts. So the key concept here is this bit. We want to work with our equation such that at the end we've got the same base on each side, just one base on each side, and then the exponents will be the same. So time to bum through. Come on, you ready? We're going to do this. Okay, excellent. So 125 to the x equals 1 over 25. So 125, we know what we're going to do, right? Well, we're going to prime factorize that. So we got, that's 5 cubed, so that's 5 to the 3x equals, well, this is 5 squared, so that's 1 over 5 squared. But you know what? I can go straight there and go, that's 5 to the minus 2. Excellent. Well, bases are the same, therefore exponents are the same. So 3x equals minus 2. Pause, take a breather, and look at it. Okay, next one. We've got 27 to the x times 9 to the x minus 2 equals 1. Now, what do you think the base is that we want to have all of these common? Well, I'm going to go with 3 because 27 we know is 3 cubed. So that's 3 cubed to the x. Now I'm skipping the step that says 3 cubed to the x. So therefore 3 to the 3x. I think we can do that in one go when it's like this. Okay, times 9 to the x minus 2. I'm going to do this in 2 goes just to make sure we get this right, but I think we're looking good. X minus 2. So that in our next step, let's just focus on this part here. We're going to multiply in, and I just want to make sure I don't mess up and write minus 2, because that's minus 4, because we got that 2 times minus 2 is minus 4. Cool. Pause. Now we got to go. Keep going. Okay, 1. 1 is 3 to the power of what? Well, 3 to the 0. Lovely little kind of nugget in there, isn't it? Of, but wait, there's 3 to the 0, right? Cool. So we got 3 to the 0. Bases are the same, multiplying. So let's add exponent. 3x plus 5x gives us 5x minus 4 equals 3 to the 0. Cool. From there, bases are the same, exponents are the same. 5x minus 4 equals 0. X equals 4 over 5. Done. Next one. Pause. Got your breather, let's go. 5 times 8 to the x plus 2 equals 80. Now, we can't just go 5 times 8 and go, oh, well, that's 40 to the x plus 2. Different terms. So, how about this? Because there are a few ways that I can think of doing this. I'm going to go for a more long-winded way to start with, because at the moment we're saying, okay, prime factorize. So 5 times 2 to the 3 multiplied by that x plus 2 equals, let's prime factorize that. Remember, do it in our calculator, and we're like, cool, pull out the calculator. I am pulling mine out, and oh, well, that's a bit extreme, isn't it? Wait, there's a calculator. There it is. Let's go big, bad, and wonderful. Yeah, I don't know either. So we got 80 equals shift fact 2 to the 4 times 5. So 2 to the 4 times 5 is what we're going to put back in here. Cool. So maybe that's what we go to start with, and we go, yeah, prime factorize, and we got bases of 2, bases of 5. Well, what's quite nice about this is if we divide each side by 5, we effectively kind of cancelling the 5s. So we're just left with 2 to the 3x plus 6 equals 2 to the 4. Excellent. Bases the same, exponents the same. So I'm going to throw this up here and say 3x plus 6 equals 4. So x equals minus 2 over a wonky 3. So I said that was the one way. We might recognize this as this type of equation, and right at the beginning divide both sides by 5. So option 2, let's see if we can squeeze it in here. Option 2 is divide both sides by 5. So we've got 8 to the x plus 2 equals 80 divided by 5. What do we get? Hello, calculator. There you are. Where's it on my screen? Whoa, I can't see it. Must be there somewhere. There, I got it. So we got 80 divided by, isn't it just 16? Come on. Yes, winning. So we got 16, right? Equals 16. Okay, now we need to make the bases the same. So now we go 2 cubed equals 2 to the 4. That's what we had before. I think this one's a bit more elegant in some ways because those 5s clearly showed themselves and we were left with the 2s. Up to you. Okay, let's keep cracking on. 2 more. 5 to the 2 minus x equals 130 minus 1 over 5 to the x. Okay, so when we have an equation, let's go for a kind of a baby equation as an example, and we had like 3x plus 7 equals 2x minus 1. What was your strategy to solve an equation, a linear equation like this one above here? Well, I guess my strategy, maybe yours is different, would be, okay, let's subtract 2x on each side so that we've got just x on one side, and maybe we therefore subtracted 7 on each side, so we had a equals, I don't know why I'm playing with colors here, minus 8. Okay, so, but the strategy that sticks out to me is rearrange it so you got x's on one side and numbers like on the other side of the equation. In other words, all your variables on one side of the equation. So let's do the same thing here. 5 to the 2 minus x is sitting over here. 5 to the 2 minus x. 130, we're going to keep on that side. And on this side here, we've got 1 over 5 to the x. So let's add 1 over 5 to the x to 1 over 5 to the x to each side. So plus 1 over 5 to the x. Okay, so that's looking a little bit better. We got all the variables on one side and our constants on the other. Now, still looks a little bit hairy, but we've got a 5 to the x. Maybe let's make it so that they're just 5 to the power of something. So 5 to the 2 minus x plus 5 to the minus x equals 130. Again, we could prime factorize that. I don't know, let's see where that gets us. So we're going to prime factorize. I'm just loading up here and going 130 equals shift fact 2 times 5 times 13. I feel like that's not going to be too great. 2 times 5 times 13. Let's just bank that one. Goodbye calculator. So here we've got 2 terms, and it would be useful if we had 1 term. So what are we going to do? Well, split and factorize. So and I'm slowing down because I think, yeah, let's actually just pause and think about this. We've got 2 terms on the left-hand side equals, now it would be nice if we had just like 5 to the x or something. So let's split this. 5 to the 2 times 5 to the minus x plus 5 to the minus x equals 130. Great stuff. So our common factor is 5 to the x, and we're left with 5 squared plus 1 equals 130. Okay, so from there, let us, well, what do you think we're going to do? Well, we just want 5 to the x on the left-hand side. So we're going to divide this side, 130. Let me show this step. 130 over 5 squared plus 1. So let me write it as 5 squared plus 1 to make it clear. So 5 to the x equals, well, 130 plus 1. 130 divided by 5 squared plus 1. So 130 divided by 26 gives us 5. Okay. So if that's 5, well, that's 5 to the 1, so x equals 1. Okay, so a bit more work to do on something like that. Last question. Multiple terms happening here. Variables on both sides of our equation. Compare this one to the previous one. Quickly jot down, what do you think we're going to do? Well, my strategy would be, and I say my strategy because there are lots of strategies, but the one that jumps out to me is, let's rearrange so we got all the variables on one side, constants on the other, we'll probably have to split and factorize and divide like we did in the previous one. So I'm going to do that in kind of one step. 2 to the x times 2 to the 2 plus 2 to the x times 2 to the minus 2 plus 2 to the x equals 42. Pause if you need. Okay, now I see our common factors 2 to the x in each of these terms. So I'm going to take a 2 to the x out, and we're left with 2 squared plus 2 to the minus 2 plus 1 equals 42. I'm going to divide 42 by this whole thing. 4 plus a quarter plus 1 to give me 2 to the x equals, calculator to the rescue. So we're going 4 plus a quarter, where's that minus? Minus 2 plus 1 gives us 21 over 4. And we want 42 divided by that. 42 divided by ons gives us 8. Excellent. 2 to the x equals 8. You know what? X equals 3. Like, this seems like an unnecessary step because it's simple enough. You can show it if you want, but come on, x equals 3. We did the hard work to get there. That's that. Exercise 3. Enjoy it. Look at them all. Yay, look how much fun they look like. Yay, are you going to enjoy it? Well, I hope you will. Goodbye.